Okay, so this is the introduction for lab number 4. I'm going to be talking about force and its relationship to acceleration. And actually it's going to be talking about a net force, and that's what the first part is about. I know that if I had a box and I pulled on it with, say, 5 newtons in this direction, and I pulled on it with 10 newtons in this direction, that this thing would have a net force, and that net force would probably be 5 newtons in that direction. So that's what the first part of this lab is all about. I just have you take some people and have them pull on a cart of different size, and different size people are going to pull with different forces on the cart. So you can kind of see I have you go ahead and have a couple of setups where I put 2 people the same size on a cart, 2 people of a different size on a cart, and then 2 of the largest people and 3 of the smallest people on the cart. So let's go ahead and pop over to the simulation and see what that looks like. You're going to click on net force, and it's pretty easy. You can go ahead and put a person on there. You do want to have these guys checked, and you can put a person over there, and you can kind of see what the net force is going to look like. So go ahead, make a prediction. Again, I don't check your predictions on whether they're right or wrong, and then go for the actual, and then get the sum of the forces for all 3 of these scenarios. Then what we're going to do is we're going to take a look at Newton's first law and realize that forces cause acceleration, and if there's no force, then there's not going to be any acceleration. And remember that the acceleration is going to cause a change in velocity. So we're going to go over to the motion window, make sure you check these boxes, and you're going to apply a force to a box and just describe kind of what happens to it using words like velocity and acceleration, displacement. There's a speedometer for you to kind of pay attention to. And then what we're going to do is we're going to apply a force, and then we're going to reduce that force to 0 and make the man stop moving. And what happens to the box, and kind of why is that? So figure out what it needs to make that box stop, and just think about Newton's first law of motion as you do this. So let's pop over to the simulation. You're going to see right down here we've got the motion thing, and you can apply forces different ways. You can use the slider right over here. You can use this guy right over there, so it'll go up in 50-meter increments, and we can go ahead and stop it. Again, please do make sure you have these guys checked so you can read off the values as you need them. Then what you're going to do is we're going to come down and do a little bit with Newton's second law. Remember that Newton's second law says that force is equal to mass times acceleration. And so what we can do is we can go to the acceleration window and we can apply some forces and actually measure the acceleration. So what you're going to do is you're going to apply a force on the box of 50 newtons, 100 newtons, 150, and 200. And those guys are all going to go right over there, and we're going to record the accelerations. And you can kind of see that if we were to divide this equation by acceleration, then we would say that the force divided by the mass the force divided by the acceleration is actually equal to the mass. So I'm going to have you divide the force by the acceleration and see if that's equal to the mass of the crate that you used. Then what we can do is we can replace that object with one that has twice the mass and do the same thing. And you're going to apply the same forces, and what you should see is if the object has more mass, it's going to have more sluggishness, and for the same forces that you applied before, you're going to have less acceleration. Still, at the end of the day, the acceleration divided by the force divided by the acceleration is still going to be equal to the mass of the block, and now I just have you do that calculation again. So let's pop over and take a look at the simulation for this guy. So now you're going to come down here and click on the acceleration, and you're going to, this time, go ahead, put all those guys on there. Something I did say was turn the friction down to 0. Now we can actually read the acceleration off, and we're going to do 50, 100, read the acceleration, 150, and so on and so forth.